Now we will understand this using this case study. Even before we proceed further with this case study, or let me provide all the details. So, how do you think banks become profitable? Banks become profitable by ensuring that they put a condition on your fixed deposits or your savings account or your current account basically. So banks would say that on a quarterly basis, you have to maintain a minimum balance of $5,000 if you want to open a savings account with us, right? This is the minimum balance that you have to maintain, suppose. And if you have 1,000 customers, it will be equal to how much? It will be equal to $5 million roughly. These $5 million are given to you all as loans. Home loan, four-wheeler loan, two-wheeler loan, education loan, so on and so forth. Based on that loan, banks get the interest. So what is the underlying factor? The minimum balance that you maintain. So the average balance that you maintain is going to determine the profitability of any card. All right, that's the domain knowledge that you need to possess. Now, say there is a university with 100,000 alumni and they're planning to launch a new affinity credit card to its alumni. So these 100,000 people are called as population. Here are two scenarios. Scenario A, do you want to do a full-fledged launch? Do you want to launch the affinity credit card to all 100,000 people? Then determine whether you're being profitable or not. If you're not profitable, stop this process or stop this affinity credit card. This is scenario A. Scenario B, rather than launching it to 100,000 people, can I do a pilot? Can I launch it to only a small subset of people, determine whether this credit card would be profitable or not, and if it is profitable, launch it to 100,000 people. If not, do not launch. Which scenario do we want to follow? Obviously, you would say that we want to go with scenario B. We do not want to go and take this big bang route and launch this credit card to all 100,000 people. Rather, what you would do? You would launch it to a sample and see whether you're being profitable or not. If you're profitable, then launch it to all 100,000 people. That makes sense. So say you have gone with scenario B and you have launched your credit card or affinity credit card to 140 people. These 140 people started using the credit card and the average balance maintained by these folks happened to be $1990. So this $1990 is the average balance of 140 people of sample. Since it's a sample average balance, it is represented using X bar. Remember, population average is represented using mu. All right. And the standard deviation of this sample happens to be $2,833. So this is your standard deviation. Now assume that your university has launched similar kind of credit cards in the past. They have launched similar kind of credit cards in the past. So you have the data of all 100,000 people of a different credit card. That population standard deviation is given to you all as $2,500, and this is your sigma because this is population standard deviation. Population Parameters are always represented using Greek letters. Now here is a question. What we can say about the average balance that will be held after a full-fledged market launch? So in order to solve this, we need to understand a few things in this. Based on the sample data, which provided you all the point estimate for the mean, which is $1990, the question is, can we trust this estimate? And the follow-up question is, what do you think will happen if we took another random sample of 140 people? So when you have launched credit card to 140 people, the average balance happened to be $1990. What if you choose another sample with another set of 140 people? Would the average balance be the same? No. You have 100,000 people. This is your population. You have randomly chosen 140 people whose average balance happens to be $1990. If I choose another set of 140 people randomly, the average balance would come out to be a different number altogether. And if you choose another set of 140 people, you would get a different average value altogether. Hence, probability associated with a single value, which is point estimate, is always 0. And this is the reason why we need to come up with interval estimate. All right. So look at this. Based on this uncertainty, we prefer to provide the estimate as an interval. And we cannot come up with an interval or a range of our choice. We always need to associate the interval or range with a level of confidence. And I've already told you that the industry norm, industry standard is 95%. Right? Look at this. This is the formula for your interval estimate. Interval estimate is equal to point estimate, which is given to us, x bar plus or minus margin of error. So even with respect to your temperature, you'll have to write it in this way. Temperature can be anywhere between 23 degrees Celsius plus or minus 7 degrees Celsius. Right? And this 7 degrees Celsius is called as margin of error. And based on this, if you want to come up with an interval estimate, it will be 23 degrees Celsius minus 7 degrees Celsius, which is 16 degrees Celsius, comma, 23 plus 7, which is 30 degrees Celsius, sorry. This is your minimum temperature, this is your maximum temperature. So this is your lower range and this is your upper range. All right, now let us actually get into the formula and calculate this. Okay, I'm just checking your, all right. So let us now actually get into the formula and solve this. Here is a formula. Interval estimate is equal to point estimate, that's your x bar is your point estimate, and this complete z1 minus alpha sigma over square root n, this complete part is called as margin of error. Margin of error. The industry standard is 95%. Yep. And what does that mean? You need to construct a confidence interval with 95% confidence level, right? So this 95% is nothing but 1 minus alpha. All right. Now, you know what is x bar, which is given in the problem formulation, and this is $1990. You know what is sigma. Assume that your university has launched similar kind of credit cards in the past. Based on that, you know the average balance of population and you know the standard deviation of population, and this value was $2,500. This is all there in the case study which we have just discussed. And the sample size is 140 there. So the only value which you do not know at this point of time is Z1 minus alpha. We do not know this, so we need to solve for this. Let us do that.